In the endless reaches of the universe, there once existed a planet known as
Caligiron,
a planet that burned like a green star in the distant heavens. There, civilization was far advanced and had brought forth a race of supermen whose mental and
physics,
powers were developed to the absolute peak of human perfection. But there came a day when giant
commies,
threatened to destroy
Caligiron.
forever. One of the planet's leading scientists, sensing the approach of doom, placed his infant son in a small rocket ship and sent it hurtling in the direction of the Earth, just as
Caligiron turned red. However, Earth was cruel and unusual. Jiffy Lube. The phone. The countless experiments. By recruiting the help of some physics students, Mr. Caligari hopes to return home. This experiment requires a stopwatch, an air pump, a rocket body, a rocket head, some valves, a meter stick, and a camera. First, assemble the rocket. Then, attach the valve to the base pad. Secure the rocket on top of the base. Then, attach the air pump to the rocket pad. After everything is assembled, begin pumping. Make sure the meter stick is visible and held accurately for the camera. Rocket launches are dangerous. Beware of falling objects and don't try to catch falling rockets. Don't stand or lean over the rocket when pumping. Always wear safety goggles. Using the footage from our trials, we can figure out the initial velocity of the rocket. Our camera recorded at 30 frames per second, so t equals 1/30th of a second. The footage shows how much the rocket traveled within one frame, which is 0.75 meters. Using v equals d over t, the initial velocity is found to be 22.5 meters per second. To find the total time of flight for the rocket, the equation v sub f equals v sub I plus at is used. V sub f will be the velocity of the rocket at its apex, which is 0 meters per second. V sub I is the initial velocity of the rocket, which is 22.5 meters per second. The acceleration is negative 9.8 meters per second squared. After plugging in these values, we find the time it takes for the rocket to reach the apex, which is 2.3 seconds. To get the total time of flight, this value must be multiplied by 2 to get 4.6 seconds. The equation d equals 1/2 at squared plus vit is used when calculating the max height of the rocket after launch. The acceleration is assumed to be negative 9.8 meters per second. V sub I is the initial velocity of the rocket, which is 22.5 meters per second. And t is the time it took for the rocket to reach the apex, which was found in our previous calculations to be 2.3 seconds. Then the max height of the rocket can be found after plugging in the values, which is 25.83 meters. To find the final velocity of the rocket, we can use v sub f equals negative v sub I. So our final velocity is negative 22.5 meters per second. The low valve setting had an average max altitude of 21.03 meters, while the medium valve setting reached 26.3 meters on average, and the high valve settings launched to 32.66 meters. The rockets launched at the initial velocities of 20.3 meters per second, 22.7 meters per second, 25.3 meters per second, low, medium, and high respectively. We notice as the initial velocity of the rocket increases, the final speed, the airtime, and the altitude of the rocket all increase as well. Although the launch went as desired, we forgot to account for airspeed, imperfect angles of launch, and the various imperfections of measuring speed in terms of misreading the meter stick as well as an unstable meter stick. The results from this lab can be improved upon by using a high-speed camera and a stable measuring device. These models were used to help Mr. Caligari escape from planet Earth. However, due to multiple sources of error, Mr. Caligari's path of travel is unknown.